everyone, my name is Sandeep and I'm the co-founder of Hashnode. So for those of you who are not aware, Hashnode is the best platform for developers to start a blog on their custom domain in under a minute. Today we are so excited to launch our first podcast called The Commit, where we invite top engineering teams operating at scale to uncover their secrets. The first episode is all about Hashnode's public APIs. So let's invite Hashnode's platform engineering team members, Sandro and Jannik, to talk about how Hashnode builds its public APIs. So let's get started.
Hi.
Hey guys.
Hi there.
How's it going?
Good
Very
so far.
good. Very good. How are you?
Excited to see where this talk will be going.
Amazing. So before we start, why don't you guys just introduce yourself a little bit?
Yeah, definitely. So I can start, Jannik, if that's all right for you.
Sure.
So my name is Sandro. I am one of two platform engineering leads here at Hashnode. I joined Hashnode about 2 years ago. Yes, almost exactly 2 years already.
Nice.
And yeah, love the work here so far. I can give you a bit background about my person, who I am, what I'm doing. So, like I said, I'm Sandro, 29 years old. I normally live in Munich, so Germany. We're both from Germany, and I live right in the south of Germany, close to Austria already. Currently, I'm in Thailand for some digital nomad trip for a month, and yeah. So I love working with AWS. I love working with the cloud. And that's also what I'm doing at Hashnode.
Amazing.
Yeah, sure. So as Sandro already mentioned, I'm also from Germany, from the northern part of it, near Hamburg. I've joined Hashnode 1.5 years ago, so a little bit later than Sandro. And it's maybe a funny side story there, how I joined Hashnode. I think Sandeep reached out to me, but at that point I wasn't sure if it was right for me because, Germany and the taxes and all the legal stuff. And yeah, so I declined it the first time, but later on Sandro reached out and I could ask him all my questions and he could wipe all my legal and tax doubts. And then I basically reached out to Sandeep again and we had a chat, and yeah, that's how I joined Hashnode as a short story. So I find this pretty interesting. But yeah, to me, I've also a web development background for about 5 years or so, and also worked with AWS for a while, and previously worked at an agency where we did like larger enterprise projects with different clients. And now I'm happy to be at Hashnode.
Amazing. I think Jannik, I initially reached out to you just before the COVID happened. I think at that time, probably remote work wasn't that of a it wasn't the norm. But I think subsequently, when everyone started going remote, it probably became easier.
That's true. That's also one aspect of it. So initially, I wasn't sure if fully remote is really for me, but it turned out even at my current job at that time, we went fully remote and everything was fine. So also that doubt got wiped. So yeah. In the end, there was no doubt left that Hashnode will be the right thing for me. So happy to be here.
Perfect. Amazing. You guys are AWS experts, right? And when we started Hashnode, we wanted to. Our goal was that we build a fully serverless app, right? And you guys are doing great work, and which is how I noticed you. And I think Sandro has been blogging on Hashnode even before he was hired. The same with you as well, I think. And that's how I came across your profiles, and which also drives one big point that starting a blog and putting the content out there can help you get noticed, right?
Yeah, definitely. So I had this discussion with Jannik already a couple of times, but like the main driver of our careers and of our but the main change in our lives was really just putting yourself out there. It doesn't matter if you're like at which stage you are. I also didn't feel like I'm like the super pro in this, I don't know, in some area of AWS. And just if you blog about it, talk about it, connect with people, it really makes a difference, because then people like you, Sandeep, find these blog posts and can ask you to join and build a company together. So that's really cool. That's a great tip for everybody to do.
It has been life-changing for me as well to like move from a pure consumer to an actual producer of content. So before that, I was on Instagram looking at all the food pics and people doing shiny things and buying stuff and things like that. And then I've deleted all of that, stopped looking at those silly pictures and joined Twitter actually, and also started blogging and put myself out there, and things have changed drastically since then. So it's huge.
Amazing. Perfect. Cool. So going back to the topic of the podcast, which is Hashnode's public APIs, why don't we talk a little bit about what made Hashnode think about building APIs in the first place? What were the technical challenges that we faced, and then we decided to build this? Let's start with that.
Definitely. So I think, Jannik, if you could share your screen for a second and show the picture of the APIs. Okay, cool. So I think the best thing to dig into this is really in a visual place. So I created a diagram and a whole blog post exactly for this topic. So maybe let's dig into this, and I just focus on APIs and why we've actually built the API. So on the right side, you see a box with APIs, and you see that we have quite a few of them. And of course, Hashnode is an early stage startup. So we started out building with different tech stacks, with different things that suited at that time. But Hashnode grew by a lot. So we had some growing pains at some point. And to come back to a more technical nature, so what we did at the beginning is we had an API based on Express. So Node.js Express server on the Lightsail instance on a virtual machine, and we used that. Once we've migrated everything to Vercel and Next.js, we made heavily use of Next.js API functions. And API functions are great, especially for building stuff really, really quick, but it gets pretty hard to maintain things, reuse things, and especially once you introduce third parties, like we have a pretty cool mobile application, they need to re-implement everything again. And that is when we've decided, okay, we want to have one centralized API, also with the background already that we will have a public API. And we also had the idea of having, or dream of having, a headless Hashnode at that moment, or a headless CMS for Hashnode at that moment. So this is when we've joined forces and really thought, okay, what is the best choice for building an API? And we started out building the central API with GraphQl.
Yeah, maybe one thing worth mentioning, why we went with GraphQL in the first place and not maybe something like REST. I think this is also due to the nature of our data model and our data in general, because it's highly relational. You can imagine if you go on a blog, then you want to get the data from the author, get all the posts, whoever liked the post, and show the like little icons of the people who like posts and stuff like that. So it's highly interconnected, and that's really easy to query with GraphQL. So you can get all the data you really need to show anything in one go. And yeah, also previously, as Sandro mentioned, we had a lot of different APIs, always for specific use cases. All of them were slightly different, because maybe for this page, you need only a subset of the data, and for another one. And then you end up with several APIs that are quite similar. But yeah, so, and all of that is way easier with GraphQL. So it was a really good fit for us.
100% agreed. I think whenever I use the playground and use Hashnode's APIs, I feel that GraphQL is the most intuitive choice for this kind of apps, right? Where you have one publication schema and you have a bunch of fields inside publication, and those things can be updated by the authors from the dashboard. It really makes it easy for these people to interact with the GraphQL APIs if they're able to see that schema, right? So I think GraphQL has been it has been a great choice to go with GraphQL as opposed to REST for this use case. Just to expand on this topic, right? A lot of people ask me how did we decide the tech stack to power the GraphQL APIs, and many people also ask why don't we use AppSync, right? Since we are so much into AWS, why doesn't Hashnode use AppSync? So can one of you elaborate on the tech stack part, and then expand a little bit on why Hashnode doesn't use AppSync?
Yeah, I can take this over, definitely. So these are great questions, especially the AppSync one. I start with the tech stack in general. So a Hashnode, we as a tech department or tech side of things, we think of Hashnode as serverless first. So we really want to build everything serverless where it makes sense. And so far, for our event-driven use cases and all the use cases we have, it makes sense to build most of that serverless. So we are fully deployed on AWS with our API and with some asynchronous work as well. And why do we want to do this? First of all, because we don't want to take any time or spend any time on managing infrastructure, of having auto-scaling policies, of all of these issues we had in the past. We don't have time for that, and we don't have money for that to spend the time on. So this is why we really want to spend our time building features for our customers. And serverless is a great fit for that. So what do you mean with serverless? In the article we probably link below somewhere, you can see all of these AWS icons. So we have our API deployed on API gateway, and it talks to Lambda. So Lambda is function as a service. And as a background, so like as a persistent storage, we use MongoDB on Atlas, which is not serverless, but kind of also a managed instance of MongoDB. These are like the main parts we use, at least for our API, so our synchronous processes. And why we didn't use AppSync in the past, I think is mainly based on also our team and our downstream services. AppSync is an amazing service. I love it. I worked a lot with it. But AppSync is really great if you have native integrations to other AWS services. For example, if all of your data lives on DynamoDB, it is a really great service because you have these resolvers, in the past VTL resolvers, and then you could simply connect it. So that was super easy. But I think there's a second side of things, how we decide on tech, which is what does the team know, and what is the team capable of doing with this technology? And if everybody is really, really familiar with Apollo, for example, and really familiar with building Lambda functions and with building TypeScript and Node.js stuff, that's when we've decided to not go with AppSync. We do use Apollo. Not sure if I mentioned this, so we use Apollo GraphQL in the Lambda, which is a great framework. I think it's the default framework for going with GraphQL, and Apollo gives us a lot of flexibility. For example, in AppSync, you don't have an executable schema. In Apollo, you have, so you can actually build constraints. You can build some abstractions on top of that, which makes it really, really powerful. So I've learned a lot of things during the development with Apollo, and so far I love it. One thing, of course, that AppSync always would give you are subscriptions. That makes it easier and not the bad cold starts. But since we have like constant traffic all the time, cold starts also don't matter. So yeah, I think that was the main reason to keep it short.
That's great. That's great. I hope this gives a glimpse into the whole tech stack of Hashnode APIs. I believe I think one argument against AppSync back when we were deciding was the vendor lock-in. I don't know if that actually had an impact on the final decision, but I remember that vendor lock-in was actually one argument against the AppSync.
It is definitely an argument against it, because then, especially if you use like these resolvers, back then we just had this weird Apache VTL language in AWS. So this is something against it, but yeah, we decided for vendor lock-in on these kind of things, I would say. So we are fully on AWS, and for us, it is fine to be locked in because we believe that AWS is doing a great job for us.
Yeah,
but this is definitely a corner of AppSync. Yeah.
Cool, perfect. That I hope explains everything. And going to the next topic, and Hashnode has the scale, right? We recently had crossed 10 million monthly views, and hundreds of thousands of blogs running on custom domains. So when you're building the public APIs, what are the most significant challenges that you faced when you started developing it, and how did you overcome those issues?
Yeah, so maybe the first thing that come into my mind there is probably the database. So Sandro already mentioned we are using MongoDB there, and actually there is depending on your instance size, there's a limit on connections. So you have to use them very wisely. And since we are running our infrastructure on serverless architecture pieces that can potentially scale out really, really fast, depending on the amount of requests, it can overwhelm our database. And that's also an issue with GraphQL specifically, because depending on what the user queries, it might execute a lot of database requests. So if you imagine a very deeply nested GraphQL query and you have different resolvers for, let's say, a user and a post and a block, and maybe you're querying a list and even a deeply nested list, and you end up with a bunch of requests that can get out of control pretty quickly. So there are a bunch of things that we do to mitigate that. So first of all, there's something like GraphQL data loaders that allows for per request batching database requests and also caching them. So if you within the same request request the same data from the database multiple times, it will go to the cache instead of hitting the database each time. And also for the batching side of things, if you have a list and you don't have to do separate database queries for each of them, for each of the items, but you can batch them into one. That highly reduces the database load and connections needed. But yeah, so there's another thing, and that's the caching aspect. That's a very important piece of our infrastructure, not only for protecting our resources, but also for making the response times really, really fast. So for the caching side, we use the Stellate. It's a GraphQL caching service. We are really, really happy to have them because they're doing a lot of the heavy lifting for us. And we also get like nice little dashboards about our latency, cache hit rates, and stuff like that. So we heavily use the cache there, and that in turn comes with the next challenge. So we have to either find some kind of trade-off between caching it for long, having really fast responses, but maybe stale data, or caching for shorter periods. Something in between might be the sweet spot, but there's also something that we leverage, and that is invalidating the cache based on events. But I think we can elaborate deeper on that later on. That's just one aspect of the technical challenges. And then, of course, the overall setup. Before you can start writing your schema and the resolvers and expanding that over time, you have to get the basics right. So the authentication stuff, rate limits, you don't want to be DDoSed or something like that. You have to protect yourself against that. So there are a lot of technical challenges there. And maybe getting back to one thing that also Sandro mentioned briefly is cold starts. So at first we thought that might be an issue with running Apollo on Lambda, because the Lambda itself can get pretty big and have quite slow cold starts compared to really fine granular resolvers using something like AppSync. But I think we really see way below 1% of all requests being cold starts. So it's very rarely the case that there's a cold start. So this is due to our more or less constant traffic. And also AWS recently, or not that recently, a few months ago, I think, announced the proactive initializations. So AWS knows your usage patterns and invokes or basically keeps your Lambdas warm if they think that's beneficial for them. So that is why the cold starts are even more decreased. So that's not really an issue for us, even though this Lambda is quite heavy, to be honest. Yeah, and all of that, like getting up with the how we create the schema and evolve everything. That's nothing that we have like invented ourselves, but we are standing on the shoulder of giants there. So we got some inspiration from bigger, hugely used APIs like the Shopify GraphQL APIs, which I love and heavily use. So this is where we take some inspirations as well.
Excellent.
Maybe just to jump in here for a second, we talked a lot about cold starts, and I'm not sure if every listener is like familiar with cold starts. Just briefly explain, the cold start refers that you have Lambda environments, you function as a service like small micro containers, and it can happen that a request that this container needs to spawn when a request arrives. And like this spawning, setting up the connections to the database and stuff like that, this is called a cold start. So the preparation of the environment until your request can actually be worked on. And this used to be pretty slow, but in Node.js environments and also like with advancements of AWS, this got pretty fast. But just that everybody knows what a cold start is.
Perfect. Thanks for clarifying that, Sandro. Cool. I think this is an excellent answer, and I think this has made a lot of things much clearer now. So since you've mentioned about caching, let's talk a little bit about how exactly we implement caching at Hashnode. For example, let's say somebody is using our playground, GraphQL playground, to fetch their top 10 blog posts from their publication, right? And once they query it, if they go ahead and publish one more blog post, will this query instantly reflect the extra one blog post, or does it take time? And how do you basically purge the cache and ensure that the edge cached queries are invalidated instantly?
So Hashnode in general, so that's a great question. Hashnode in general lives on an event-driven architecture. That means if some action happens, our API emits an event to an event broker. For example, like you said, somebody publishes a post, we have a post publish event, and then there are like tons of actions and tons of consumers. And one of these consumers is exactly what you say, a purger, and this one purges some cached items. For example, if I query my top 10 posts of my blog, or my first 10 posts, and I query a new one, I have a consumer that this will be purged. So the cache will be invalidated. And that means this request will go back to the downstream system, to the API and to the database, and then will be cached again. The whole thing is edge cached. So we use Stellate for that. Jannik briefly touched this. So we use Stellate for that, and we edge cache everything depending on where fastly the network is. And yeah, we invalidate on like tons of actions. We have, I think, 79 different event types, and on post liked, on updated, on removed, on if you do something on your publication. So you need to cache and need to invalidate several things. And as we all know, this is one of the hardest computer science problems. But I think so far we are quite good, and we do it quite successfully, hopefully.
Right. So just one more question on that. So we have different types, right? So do we basically add some cache duration to these specific types on Stellate side? Can you shed some light on that? How exactly it works?
Yeah, so we are currently caching based on queries, but you have a lot of flexibility with Stellate. You can cache based on certain types and have separate rules for certain fields. You can imagine that, for example, a post may include some user-specific data that you don't want to share the cache with all the people. So you can also set up scopes like an authentication scope that it's only if that single field is requested, then the cache is not shared with everybody, but only within that same scope and stuff like that. So there's a lot of flexibility there. And also maybe one thing mentioned there, usually if you go all in on Stellate and only have GraphQL to query and mutate your data, you probably don't have to purge the cache yourself. So there's something like auto purging where they actually, based on your schema, detect that you have changed certain data through a mutation and then invalidate it automatically. But since we still have some legacy APIs in use and not only mutate our data through our API, we are making use of our own event data structure and purge the API through API calls. So there's a lot of flexibility there. That's a very crucial part of our infrastructure.
That makes sense. So this means as a Hashnode user, I can be assured that my queries are always cached at a location which is geographically closest to my readers. And I can also be assured that every time I update my publication, or every time I create a new post, or let's say I update a post, that those cached queries will be purged pretty much instantly, resulting in fresh content.
Exactly.
Yeah.
Exactly. And I think the important point here is at the closest location, because this is a concept which can get also quite complex, edge computing versus central computing. And I think one component we need to add to explain this fully is Vercel. So we are fully deployed on Vercel with our front-end applications, or let's say with our Next.js applications. And Vercel also offers a cache. And what Vercel especially does is it is offering a page cache. That means the whole HTML is cached on the edge and not just the API response.
Yeah.
And we use stale while revalidate there. So it is cached there for a really, really short time period in the end for us, because for us, it's not so easy to invalidate this one. So it's cached for a really short time period at the closest location to the user. And then once this gets revalidated, it can be that we hit like a central location again, and the central location again hits the API cache. I think this is really well explained in the engineering blog post we linked down below, but also thinking about caching and going from edge computing to central computing, having get server-side props, sometimes run on the edge, sometimes not, adds a lot of complexity and some round trips you need to be aware of. But yeah, I think this is definitely worth mentioning in this context.
Cool. That makes a lot of sense. All right, I think we have addressed the biggest part, which is caching. Now, moving on to the next topic. It's one thing to build a public API, but I think it always has this ongoing investments in terms of maintenance, right? So how do you guys maintain these APIs? How do you ensure that they're always up to date and they're managed correctly? And if you have any breaking changes, you do it in a way that it's not disruptive. So can you talk a little bit about that?
Yeah, definitely. So how we maintain the API, I think the main part, what is different from Hashnode's API to many other APIs, is that we actually use this API internally for hosting our product and for powering our product. And this is also our intention, that we only publish an API resolver or some API query if it is battle tested that we use it on our scale. And if that works out, then we go out and the public can use it. It takes maybe sometimes a week or two longer that we can battle test it, but then we really find all edge cases, right? Because we have a huge scale and we have all weird edge cases, and then it's battle tested for them, and then people can power their blogs with these queries. So this is one large part for maintaining the APIs for us. The second one about updating them is prioritizing them heavily. So I would say, as always in a startup, we are like tight on resources. That means on developers. So we really need to understand what is it that people need. So we talk to customers a lot. I know Sandeep and Fazl, our CEO, is doing this a lot. So to like the people who use Hashnode the most, who use headless Hashnode, who host their whole company blog on Hashnode, then we understand what are they needing. So do they need more queries? Do they need more fine granular permissions? So to understand these things, and that is how we build, and then we go all in on building these functions and battle test them internally and getting them out there.
Perfect.
Yeah, I think one important thing there is that it's really a mind shift for us. So previously we were mostly using private internal APIs, and it's easy to add a field here and there and change them. But with the public API, that's different. So you really have to make your changes intentionally and think of potential breaking changes in the future. So it's not that easy to add new things, or especially because you don't want to have to remove them later on, because that would be a breaking change and stuff like that. And that is why we have to change our mind there a little bit and put some more thought into it before adding and changing the API. And with GraphQL, you also have you can, for example, add a new field that's different to previous field just a little bit and deprecate the old one. And after some time of notice period, you can remove the old one and stuff like that. So you can evolve your schema over time, and not have to version them. Then, for example, with REST, you often see V1 in the URL itself or something like that. And later on it's V2, and you restrict your breaking changes to this version changes. With GraphQL, you can also evolve the schema over time by deprecating certain fields and then removing them after a deprecation notice period and stuff like that. But these are also things that we have to get used to, since previously we were mostly using internal APIs. So it's quite something different, to be honest.
I think this also has a lot of positive effect, because since we know that this is going to result in a breaking change, we put a lot of effort and emphasis into thinking about the field names before we release them. And when we are doing development, we are obsessed about naming them correctly, right?
That's like the second hardest problem is naming.
Yeah.
And it is definitely hard for us.
Caching and naming things will all come together here.
Yeah. It looks like we're handling them really well.
Hopefully.
Cool. Do you have anything else to add to it, Jannik? I think.
Yeah, maybe one thing to mention there is really think about the usage of the API. What are people doing with it? So if I think of, for example, building a headless blog using Hashnode as a headless CMS, and they want to consume their content via APIs, then it's not only about the APIs, right? But also the things around it. So if you imagine, like, for example, I think you, Sandeep, are also using headless Hashnode on your subpath. If you want to host it then yourself, and you also want to cache things on the edge, for example, like Sandro mentioned, or you even want to go with a static page. For example, you think like Astro may be a good use case or a good framework for a blog because the content is mostly static and not changed that often. But in the end, you have to somehow rebuild or invalidate your cache if things change. So Sandro mentioned we internally have our event-driven system there. We can, based on if a post has been published, purge the cache and stuff like that. Users don't have access to our internal events, of course, but that's why we also released the webhooks recently, which is also a crucial part. And there, for now, you can do something based on create, update, and deleted events of your posts. So, for example, if a post gets updated, you can wipe your cache by reacting to a webhook request or rebuild your page or whatever you want. And this really plays nicely together with the APIs. So this is another crucial part. So it's not about having a too narrow focus on the APIs only, but also on the actual usage of them and how they are used out there.
That makes a ton of sense. Thanks for saying that. And just to recap this for our listeners, I think Hashnode decision to first use these APIs internally before releasing it to the public, I think that has been one of the best decisions that we have taken. That way, we are always aware of the whole experience, and many times we're able to spot a lot of problems with the APIs and with the whole UX and implementation before we release them to the public. And which means there is a less chance of making breaking changes. And before we hand it over to the users, we have already implemented it on our end, so we know that it's not there are not much or many edge cases, or they're not or that it doesn't create a lot of bad experiences while implementing. All right. Cool. Since we have taken care of caching and naming things, let's move on to even bigger problems. So, which is the speed and performance, right? At Hashnode, we are obsessed about speed, and the whole idea of offering speed as a feature that fascinates me personally so much, and which is why we are so much into edge caching. And I think Hashnode has a latency of less than 100 milliseconds from most areas across the globe because of our edge caching. So when Hashnode decided to build the public APIs, we definitely considered performance to be a big deal, right? So how do you optimize, or rather, how do you measure the performance continuously, and how do you ensure that it's always optimal, and how do you optimize it?
So for measuring API requests, we also make use of Stellit, or at least Stellit gives us a nice dashboard for that. In general, API performance is measured in milliseconds, and you measure the latency. So how long does it take to send a request and get a response back? And we do the whole thing in percentiles. That's typically like you have a P95 percentile, so 95% of the requests are within this range. And for us, the range in like overall the globe is 300 milliseconds to 295 milliseconds at the moment. And that means that 95% of these requests are within 295 milliseconds. This is quite good, quite okayish, I would say. So we are happy with that.
Yeah.
And what you also said, so what is important to understand here is that this is the API we are talking about. So if Sandeep mentions, for example, the 100 milliseconds of direct access, this is what I've meant earlier with the page cache. So once I go to a page, it normally loads instantly because it's cached on, like the whole page is already cached.
Yeah.
Where we also need to be honest is the whole thing about edge versus non-edge computing. So we definitely see much better data in North America. So it's way faster in North America. If I would need to check, but it's definitely under 200 or 150 milliseconds, the same thing, because everything is just, the infrastructure is amazing in the States. And also Vercel database and stuff like that. Most of this runs just in North America, somewhere in USES1 probably. So there, the performance is even better, but we try to have it all over the globe as well. A second thing we measure, especially since we have Stellit and they give us the data that easily, is the cache hit rate. So how many requests are cache hits and how many requests are cache misses. And this is just a percentage. So in our case, we had 40% cache hit rate. This can be improved by a lot, but still that means 40%, 4 out of 10 requests are a cache hit, which is pretty good. And the majority of these are, of course, post pages and post pages. So if somebody goes to my blog and reads a blog post about something, then this is most probably always a cache hit.
That's nice. And just to recap a little bit, we are talking about both APIs caching, API level cache, and also page level cache, as you mentioned, right? So we use both of them, right? So Stellit automatically caches the public APIs, and since our front end is on Vercel, we also edge cache the whole HTML at edge locations, which provides us with a much better latency across the globe. But yeah, I mean, we are as I said, we are super obsessed about speed, and we are constantly optimizing it. And I'm sure the cache hit ratio is probably going to go up to a much better value soon, right?
Yeah, we already increased it by a lot. Yeah, but that is to improve it even further.
Amazing. So coming back to another important topic, which is webhooks. When we talk about public APIs, we also kind of think about webhooks. So what kind of webhooks does Hashnode support? And I think there is also an interesting story behind how webhooks was built. Why don't we talk about that?
Yeah, let me start with the story first. Yeah, a lot of the recently announced great Hashnode features are based on our internal hackathon. So I think, Sandeep, you mentioned on Twitter already that I think someone asked why Hashnode is now releasing so many awesome features and what we have changed internally. And I think you said that we are hackathon-driven development is what's going on by Hashnode, and I found that really funny. But yes. Yeah, also this webhook thing is something that Sandro and I have created during the hackathon. We have polished it a bit after that, but basically it's a hackathon idea that came to life there. So I think within 5 or 7 working days, we have created the main functionality there. And we started with the most important events. So this is like the post-related events. If posts have been published, updated, or deleted, you can listen to those events and trigger webhooks to a URL that you specify. We append some signature there so that you can make sure that the event actually originates from us and not someone else is calling your API or something. And it also only contains the very basic information I think currently it's only the post ID, for example. And if you not only want to trigger a cache invalidation, but also want to really update anything or use the webhooks for doing backups yourself or whatever, you can also leverage our GraphQL APIs. Use the ID from the webhook request, query our GraphQL API to get all the data you need for that post and do with it whatever you want. So yeah, so this is the background story there. And I think for our presentation of that feature, I built a quick demo where I trigger a function based on these webhook requests. And this function in turn triggers a GitHub action. And this GitHub action queries our GraphQL API and updates my GitHub README. So if you go to my GitHub profile, then you always see my latest blog posts there. That's also pretty neat, I think.
That's neat. I
That's
think
definitely.
yeah, I think one more example will be that since I am using my Hashnode blog as a headless mode, this means I can actually run my whole. I can cast the whole blog front end forever, right? Until the contents change. I could utilize the webhooks to trigger this Next.js front end revalidation only when the content change, and which means I'll get a lot of performance benefits and cache it on my end, right?
Yeah, maybe you don't even want to run a server yourself, but only host static fields. You can
Absolutely.
you can use our API, like generate some static fields with it, put them on S3 or something, and only update them based on our webhooks. So you have all the flexibility that we have ourselves, of course, with currently still a very limited events triggering APIs, but I think we're currently working on the same events for static pages, for example, and there will be more to come. So also people out there give us feedback, which requests or which events do you need to build your things. Then we try to add them. So we are improving and expanding there as well. So it's just the start there.
That's nice.
Yeah. And I definitely think since we both developed it, this was Jannik's baby, so he talked about this feature idea for quite some time before. And I also think one thing which enables webhooks is just, if you think about the target customer being just like the individual developer, you maybe can simply click on a redeploy and your whole blog redeploys, and that's fine. But since we started migrating a lot of enterprise customers and having huge companies using Hashnode, and normally companies and enterprises, we all know, have pretty complex and sometimes legacy systems. And that's a great thing about having a REST API or REST webhook in that case, that they can get super flexible. So they get a notification, they can do whatever they want with that. This is also why it's so popular for companies like Stripe, like all of these payment providers, for all other CMSs as well, to use webhooks, because it enables a lot of flexibility on that side.
Maybe
Sure.
one important thing to mention here, getting back to the origin story of webhooks, is that the webhooks were actually the project that won the hackathon. So yeah, so it's not us, not only us who loved it, but also hopefully Sandeep and Fazal, who decided the winners. Yeah, we think it's pretty useful for the users out there, and you can find them in your dashboard, on your blog dashboard under webhooks, and configure them there. And there are a lot more features related to that. So you can see the latest requests and the status, the payload and response, and the latency and the headers, and you can retry them. We also automatically retry them for you up to 3 times if they fail with an error status code, and all of that are like I would say, like, most important features of webhooks. Also there we got inspiration from other companies. For example, Stripe, we think, have really great webhooks. And so, yeah, again, standing on the shoulders of giants there and taking inspirations from others. This is what makes this feature really good from our perspective, I think.
I think the whole webhooks has been implemented really, really nicely by you guys. And I think this is done so well that this probably deserves its own article or tutorial on how we built the webhooks probably if there is enough interest from the listeners, maybe you guys can create some content around it.
Yeah,
Good point. We
I
should
said
do
the
that.
same thing because it is interesting how we've implemented like serverlessly with step functions, retries, and stuff like that. It is really cool. So we
Yeah.
should write an article about that.
So there's a blog post upcoming soon then.
For sure.
Yeah, by Jannik.
Okay. All right, cool. So I think we have covered quite a few things on this call. So just to conclude this podcast, I will ask you one last question, which is, what was your key personal takeaway from working on this? What did you learn, and what kind of personal learnings did you get?
Yeah, that's a really good question. You need to think about it. What I instantly know or what I instantly can think of is that building a public API is much, much more harder than building an internal API. You're super flexible with an internal API and you're not flexible anymore with a public API. I had this the first thing when I built a mobile application, like as a side project. There you already have the problem that you need to support all versions down there. And the same thing applies to an API. So without giving it too long, this is definitely one thing that is something worth considering. If you as a company decide to build a public API, understand what you're doing and understand what you're deciding, and then do it properly, because you don't want mad developers that can't use your API or that you break their systems all the time. So this is the first thing I would go through my points I have in mind. Then you can go ahead, Jannik. The second thing is what always applies, I think, is talking to customers is key here. So we always had in mind building something, and I think it takes a bit of gut feeling especially from the founders, so from you guys, what we should do. But once we are doing it, I think involving the customer as close as possible. For example, with customers, we have close Discord channels or Slack channels where we discuss their daily work, how they create a blog post, what are tags for them, are these categories or not. So like all of these minor things where we think they are true or they are correct, it's always worth validating with the customer and understanding what they are doing. And I think we're doing, and you are doing a great job here. So talking to customers is definitely key. And the last part is outsourcing everything which is not our core competency. I said it earlier about serverless. The same thing applies to everything. It doesn't matter, for example, you build an image CDN by ourselves. We didn't build a CDN for GraphQL caching ourselves. All of this stuff is really things we don't want to do, or we maybe would like to do, but this is not like our core competency. Pay people money for them and pay them well. That's fine if their SaaS are expensive, but concentrate on your customers and build for them, and don't build tech yourself.
Absolutely, 100% agreed with that. What about you, Jannik?
Yes. Yeah. So from my side, I think the key learning is that no matter how much effort you put into to really get the GraphQL schema right from the get-go, it will never be perfect, and you will have to change things. And I think something that we did right from the very beginning is having an API guideline, which is like a Notion doc, an internal one. I have also written about that previously on a blog, where we have like the basic things like how we want to name stuff, and is it uppercase, lowercase, how we want to deal with pagination and all these things that would also be breaking changes if you get them wrong and do them wrong. You can at least those seemingly little things prevent being wrong from the beginning by something like an API guideline, which is really helpful. But yeah, so in the end, there will be always changes, and no matter how hard you try to get things right from the beginning, but that's definitely a key learning. So yeah,
perfect. So yeah, so sounds good. And I think we have covered pretty much everything, and we have learned so many things, and I hope our listeners might have gained some value out of this. And one thing that I'm personally excited to do is read your blog post on how you built the webhooks, right, in a hackathon, and won the first prize. Whenever you're ready, I'm happy to read your draft.
Sure.
right?
No pressure on my side, right? But yeah, I'll have to get to it. Yeah.
So thank you guys. Thank you guys for spending time with me on this podcast. This is our first podcast, first episode, and I hope this was interesting and valuable for everyone. Thank you so much, guys.
Thank you as well, Sandeep. It was really great. I really like it.
Thanks for having us. Yeah.
So that was our first episode with Hashnode's platform engineering team members, Sandro and Jannik. Follow and subscribe to us on Spotify and YouTube. Thanks for watching.